All right, today we're going to pull back the curtain on something that's absolutely central to modern web development, but a lot of people don't really know how it works. We're talking about React Fiber. It's basically the secret sauce, the engine that makes the apps you use every day feel so snappy and fluid. So let's dive in and figure out what's going on under the hood.
You know that exact feeling, right? You're typing something, scrolling a page, and boom! Everything just locks up. The whole interface just hangs for a second or two. It's super frustrating, and it's the exact problem that React Fiber was built to solve.
So to really get to the bottom of this, we're going to use a little analogy. Just imagine that building a user interface is like being a chef who's trying to prepare a huge, multi-course meal. This whole idea of a chef in a kitchen is going to be our guide for the next few minutes. Stick with me.
That freezing, stuttering feeling, well, it actually has a name. Developers call it jank, and it used to be a huge problem because of how the first versions of React were designed. Okay, so let's go back to our chef. The old React chef was, well, single-minded. Once they started cooking a big meal, you could not interrupt them. For anything. A customer needs a glass of water? Nope, gotta wait. A new, urgent order comes in? Too bad. The entire meal had to be 100% done before anyone got anything.
And this whole impatient chef approach, it has a technical name. It was called the stack reconciler. And for the first few years of React's life, this was how everything worked.
Now, the reason it couldn't be interrupted is because of how it worked. It would just dive deep into all the work that needed to be done one piece at a time. And once it started that process, it was all or nothing. It was one single unstoppable job that had to run to completion before the browser could do anything else.
And the consequences of that were not great. Because this stack reconciler couldn't be paused, it would completely block the main browser thread. And that meant the browser couldn't respond to your clicks, it couldn't process your typing, it couldn't run smooth animations. The result? You guessed it, jank. Lots and lots of jank.
And this wasn't some small fix. We're talking about a fundamental ground-up rewrite of React's core. You can see here, for years React used the old stack. But then 2017 hit, and with React 16, everything changed. Fiber was introduced. And that new foundation is what made all the incredible concurrent features in React 18 possible today.
So if the stack was the problem, Fiber is the brilliant solution. Let's check back in with our chef and see how things have changed.
Our new chef is way smarter. They're in the middle of a huge task, right? Chopping all the vegetables for the dinner rush. But if a customer over at table 5 just needs a glass of water, an urgent quick request, the chef can actually pause chopping, go serve the water, and then come right back to the cutting board without missing a beat. That ability to be interrupted is the whole idea behind Fiber.
And that one ability, to pause and resume work, is a total game changer. It means Fiber can prioritize. An urgent update, like you typing into a search box, can be handled right away, while bigger, less critical tasks can wait. The main thread never gets blocked for very long, so the UI stays totally responsive and you get those buttery smooth animations we all love.
So how does this actually work? I mean, it sounds like magic, but it's really just some incredibly clever engineering. Let's take a look at the core idea that makes this all possible.
So here it is. Fiber isn't just a cool name, it's literally a new data structure. Instead of thinking about the UI update as one giant single task, React now breaks all that work down into a list of small, bite-sized chunks. You can think of each one of those little chunks as a fiber. This lets React work through its to-do list one piece at a time, and it can pause between any two chunks whenever something more important comes up.
But wait a second. That brings up a huge question, doesn't it? If React is pausing the rendering process halfway through, shouldn't you see a weird, broken, half-finished interface on your screen? But you never do. So why not?
Well, the secret is a technique that's actually borrowed from the world of video games. It's called double buffering. React basically keeps two copies of your UI in memory. First, there's the current tree. That's what you're actually looking at on the screen. But meanwhile, completely behind the scenes, Fiber is building a brand new work-in-progress tree. And even if that work gets paused a dozen times, it doesn't matter because you, the user, never see it. Then, only when that new tree is 100% complete and ready to go, React swaps them in a single, lightning-fast operation. Pretty clever, huh?
Okay, this is all fascinating stuff about how React works inside. But why does it matter to a developer who's actually trying to build an app? Well, it matters because this entire architecture unlocks incredibly powerful new tools for them to use.
This right here is what it looks like in the actual code. By wrapping an update in this function called start transition, a developer can literally tell React, hey, the stuff happening inside here, like updating a list of search results, it's not super urgent. You can interrupt this if something more important comes along, like the user typing another letter.
And that is the whole point. Fiber isn't just some internal performance boost. It's a huge shift that gives developers fine-grained control to make sure that the most important user interactions always feel instantaneous.
I mean, when you put them side by side, the difference is just night and day. With the old stack, you had no interruptibility, no way to prioritize work. Things like concurrent features were just plain impossible. Fiber gives us all of that and more. It's a total evolution that enables a whole new class of powerful, user-friendly applications.
So, if you remember one thing from all of this, let it be this. The old stack reconciler basically fought against the browser. It would just hijack the main thread and block everything. Fiber, on the other hand, is a cooperative partner. It does its work in tiny chunks and constantly yields control back to the browser, making sure the user's experience is always the #1 priority. And that kind of leaves us with a pretty fascinating thought for the future. Fiber gives developers the tools to tell the application what's important. But what's next? What if our apps could become so smart they could actually predict what's important to us based on our behavior, ensuring the UI always feels like it's one step ahead? That's the kind of future that React Fiber makes possible.